Hello everyone, myself Purushotham, working as Assistant Professor in Department of Computer Science and Engineering, MLR IT. In this session, I am going to discuss about thread class method. So, this is the overview of this session. So, in this session, I am going to discuss about the yield method, the join method, is live method and some sample examples I am going to discuss now. Okay, so in last session, so some more thread class methods are discussed. So, now I am going to discuss a few more thread class methods, yield, join and is live. Okay, so let's get started today's session now. So, first yield method. Now, what is a yield method? So, suppose if you take a scenario, like suppose assume there are 3 threads, T1 thread, T2 thread and T3 thread. Okay, so on CPU, so these threads are in the waiting state, assume. So, T1 is waiting state and T2 also waiting state and T3 also waiting state. So, these 3 are in the thread pool and these 3 threads are waiting for the CPU. Now, assume the T1 gets the processor and starts the execution and T2 and T3 are in the ready and runnable state, means, so now the T1 got a chance to execute on the CPU. Now, the T1 is executing here. Now, there is no T1 in the waiting state. So, in the waiting state, we have only T2 and T3. Now, so the completion of the work of the T1 is a 5 hours and for T2 is a waiting just for 5 minutes work. So, assume. Now, the T1 is executing on CPU and T1 is taking the time for about the 5 hours of time. Now, just for the 5 minutes of time, the T2 must be wait until 5 hours. Okay. So, this is the scenario of this problem. Now, to avoid this type of problems, so if any long running threads are executing on CPU, if you apply the yield method, so the yield method what it does means, it will check in the thread pool for every specified seconds and it will check for what the highest priority of the thread, any other thread is in the waiting state and it will give the chance to the execution. So, that is the idea of using what? The yield method. Now, if you apply the yield method on the T1, now what will happen means the T1, the yield method, so every time it will check in the thread pool if any highest priority threads are there in the thread pool. So, every time it will check. If any highest priority threads are waiting for the CPU, it will stop the execution and it will yield the CPU to that higher priority threads. Okay, that is the idea of yield method. Okay, if you observe this diagram, you can see here. So, assume here I have what the T2 and T3 are in the waiting state and the T1 is executing the 5 hours of time. Now, T2 is waiting state and so T2 job will be done within the 5 minutes, but the T1 is executing on CPU for 5 hours of time. Now, if you apply the yield method, now what will happen means it will check in the ready queue, is there any highest priority threads are there in the waiting state. So, it will check every time. If any highest priority threads are there in the waiting queue, so now the T1 will be stop the execution and it will hand over what CPU to the highest priority threads. Okay, that is the idea of yield method. Now, here, so suppose assume the T2 is having the priority, let us take an example 6 and T1 is having the priority, let us take an example like T1 is having the priority is a 5. Now, the T1 is having the priority 5, but in the waiting state, T2 is having the priority 6 and the T3 is having the priority 1, assume. Okay. Now, in waiting state, the T2 is in the waiting state with the priority is a 6. Now, what will happen means the T1 will be stops the execution and it will enter into the runnable state and it will hand over to the CPU to the T2. Okay, only highest priority threads will be executed. Suppose if you take a scenario now, so take one more scenario. Now, the T1, T2 and T3 and again same story. So, T1 is executing for 5 hours of time and T2 require only 5 minutes of time. Now, let's take an example. So suppose the T1 is having the priority, suppose let's take an example like 8. So priority 8. Now the T2 also priority 8 and T3 also the priority 8. So if the same priority means, so it may give, means thread 1 may give chance to what the waiting state threads, or it may not give. Okay, it depends on in such case. Okay, so all threads are having the equal priority. So here we cannot predict exact output. So here, so who will decide this execution order means a CPU scheduler algorithm, means a thread scheduler algorithm. So thread scheduler will be decide what execution. Okay, so this scenario we cannot predict exact order. So here whenever you are applying the yield method, simple, if any long running threads are executing on CPU, just it will stop the execution temporarily and it will enter into the what the waiting state, means a runnable state it will enter, and it will give the chance to other waiting threads which are having the highest priority. Okay, so that is the yield method. And so whenever thread calls like a thread dot yield method gives a hint to the thread scheduler to it's ready to pass the execution. Just if you are using the yield method, it will give the what hint to the thread scheduler. Okay, so if is there any waiting, is there any highest priority threads which are there in the waiting state, just we are giving the hint. So this hint may be ignored by the thread scheduler. This hint may consider the thread scheduler, and sometimes this hint may be ignored by the thread scheduler. Okay, so if any thread executes the yield method, the thread scheduler checks is there any thread with the same or highest priority in the thread. Okay, so already explained this point. Okay, so whenever you are applying the yield method, so the yield method it will verify in the what waiting state, means thread pool it will check. So is there any highest priority threads are with the same priority threads, is there any threads are there in the waiting state, it will check. If it is not there, so highest priority means that thread only will continue. If any threads are there in the waiting state with the highest priority, so the execution will be stopped and it will give the chance to that particular thread. So one more the predefined method is there in the thread class, so that is a join method. So join also one of the predefined method, so which is defined inside a thread class. So join also one of the predefined method which is defined inside a thread class. So here if you want to work with the what join method, so here we need to handle this exception, interrupted exception. So the join method is throwing what interrupted exception, and it is what the checked exception. It is a checked exception. So compulsory you need to handle using what the try catch. Compulsory you need to use what the try catch, or if you want to bypass you need to use a throws keyword. It depends on your requirement. Okay, if you want you can handle by using the try catch, or if you want to bypass the exception you can use a throws keyword, but the compulsory we need to use any of this approach. So what is a join method before that? Okay, so the join method, see here, if thread want to wait until the completing of some other thread, then we should use what join method. Okay, means in general all threads in the multi-threading environment it will execute independently. A thread itself is an independent part of the program. Okay, so suppose if you take an example like CPU, on CPU T1, T2, T3 and T4. Now the 4 threads are executing. Now the 4 threads will be executing on CPU, so we cannot predict the exact order. Okay, sometimes T1 may execute, sometimes T2 may execute, sometimes T3 may execute, sometimes T4 may execute. Okay, we cannot predict the exact order here. Why? Means every thread in multi-threading environment is an independent part. The independent part means, so they are having one separate space and they will execute independently. Okay, but here sometimes we may have such type of requirement. Sometimes we need to make some threads interdependent. Okay, so let's take an example. So take a scenario. So assume I am developing a exam portal application. In exam portal application, so assume I have 3 threads like T1 thread, T2 thread and T3 thread. So exam portal application I am developing. Now to conduct exam, the first of all we need to announce the date. Okay, so first we need to announce the date. So date announcement. So date announcement. Next, T2 is hall ticket generation. Hall ticket generation. Next, T3 exam conduction. Assume I have 3 threads. So the thread 1 duty is what? It will announce the exam dates, and thread 2 duty is what? It will generate the hall ticket, and thread 3 duty is what? It will conduct the exam. Now suppose in multi-threading environment, if you are not using the join method, what will happen means T1, T2, T3 will be executed independently. Now if you take a scenario like a CPU, on CPU these 3 threads are executing. Now what will happen? Now we will see T2, T3 and T1, T2, T3. So these 3 threads are, if you are not applying the join method, 3 threads will be executed independently. So suppose assume the T2 got a chance to execute on the CPU first, what will happen? So without data, so hall ticket will be generated. Okay, now what will happen? So in hall ticket compulsory we need to specify the date, means thread 2 is depend on the thread 1, but here it is executing independently. So without announcing the date, so T2 is executing and it is printing a hall ticket. And suppose take one more scenario. Now the T3 got a chance to execute on CPU before T1, T2. Now T3 got a chance to execute without date announcement, without hall ticket generation. Now if you are conducting the exam, that is a meaningless. Means T3 is a depend on the T2. Now the T2 is depend on T1. So here sometimes thread may be depend on each other. Okay, in such cases, in such scenarios, we need to use what? The join method. So simple. If you want to make the thread interdependent, we need to use the join method. If you want to make the thread interdependent, we need to use a join method. So how to work with the join method? Now we'll see. So a sample example, that's the same story. Just now explain the problem. So exam portal application here I am developing. Now here I am using 3 threads. One is a thread 1, thread 2 and thread 3. So thread 1 duty is what? Exam date announcement. Thread 2 duty is what? Hall ticket generation. And thread 3 duty is what? Exam conduction. Now here after starting the T1, next thread 2 must be executed. Okay. Now the thread 2 must be use what? The join method. Means if any threads are there in the waiting state, that must be wait until completion of the T1. Okay, that is the idea here. Now the T2, after T2 is done, now the T3 must be executed. Now on T2 also you need to apply what? The join method. Means if any threads are executing while executing the T2, that must be in the waiting state. Okay, so here the compulsory we need to use. And the T3 also, if any, here also we need to use what? The join method. Means if any other threads are there in the waiting state, that threads also must be in the waiting state. So compulsory we need to use T3 dot join. If you are not using the join method, what will happen means the thread will be executed independently. Now you can see here, if you observe, so exam date announcement thread is executing the first time, means the T1 is executing first time, and T2 thread is executing the next, and T3 thread is executing last. Okay, the same program. Now I will explain the programmatically now. First of all, so in multi-threading environment, if you want to create a thread, so we need to take our own class. So here I am taking my own class. So the class name is a thread class, my thread, and extends with thread class. So this is the first step, and here I am overriding the run method. Inside a run method, I want to print a message for 10 times, like int I equals to 0, I is less than 5. Okay, I will print 5 times. And so whatever the thread is executing, I want to know that thread. So for that, so I will write like current thread current thread method also part of the thread class. It will return the currently executing thread. So now I want to name, so which thread is executing, that name I want to print space is executing. So that message will be print. So suppose exam date announcement thread is executing means exam date announcement thread is executing, or hall ticket generation means hall ticket generation is executing. Exam conduction thread is executing means exam thread conduction is executing, like that it will print. Okay, it will print for 5 times. Now here I will create a thread like my thread. So let's take an example T1, okay, T equals to new my thread. Next. So here I will take the T2 and the T3. Now the T1 dot start, T2 dot start, T3 dot start. Now these 3 threads I am executing without customizing, and 3 threads are executing independently. Now what will happen, you can see here. Now 3 threads are not customized threads. This will be executed like thread 0 is executing, thread 1 is executing, what thread 2 is executing. Means here if you are not specifying the names, so by default it will take the names like thread 0, thread 1, thread 2, thread 3, like that it will take. Now the thread 1 I want to renaming to what? Before starting itself we need to use this method set name. So set name I will write like exam date announcement, exam date announcement. So exam date announcement thread will be executed same the way. Next I will customize the thread like thread 2 set text hall ticket generation, hall ticket generation. Next thread 3 set text, set name exam, so conduction. Now 3 threads are customized. Now you can see without using the join method, now you can observe here exam date announcement is executing, and immediately without a hall ticket generation exam conduction thread is executing. So here we are getting what? Abnormal result, right? So this must be execute what the sequential order, and these 3 threads must be interdependent each other. I want to make threads interdependent. Now how to make interdependent means, after starting T1 and T1 thread, T2 and T3 must be in the waiting stage. So I will call what? The T1 dot join method. Next after T2 is executing, the remaining thread like T3 thread must be in the joining. No? So T2 dot, you need to call the join method, and T3 thread also we need to call the join method. Okay, now here make sure that here compulsory we need to handle the exception. You can see here the join method, if you are applying in your program, so compulsory you need to handle the interrupted exception. As we know that interrupted exception is a checked exception, either you need to handle by using the try catch or you can use a throws keyword. So here I am not handling, just I am bypassing interrupted exception. So just write interrupted exception like this. Now if you observe, now you can see 3 threads are executing one after another. You can see exam date announcement is executing, that thread, first thread is executing, then only the second thread is executing, hall ticket generation is executing, and lastly exam conduction thread is executing. Even if you run this program the multiple times also, you will get the same output. Okay, so this is about the join method. And so one more method is alive method. Okay, so is alive method means, as name suggests, it will check whether thread is alive or not. It will check, means if the thread is currently running on the CPU, so it will check, it means if the thread is currently running on the CPU, it will return what the boolean value, means it will return the true. If the thread is not alive, means it will return the false. Means you can see here, this is alive method is returning the boolean value. The boolean means either it will return the true or it will return the false. And so current thread, as we know that it will return the currently executing thread, means whatever the thread is executing the currently, that particular thread will be executed here. So how to know that current thread, means we need to apply the current thread method. So if you want to know the current thread is executing, current thread name or current thread ID, or you need to use what the current thread method. Okay. So these methods, now I am going to explain the programmatically now. You can see it's already there. You can see here. So if you observe this one, here I have a thread, I created object, I have a thread, and I am verifying whether thread is alive or not. Before starting what the thread I am verifying. So T1 is executing, is alive or not, here you may get what the false, you will get the what false. Why? Before starting any of the thread, so you will get what the false as an answer. Why? Means before starting no new thread will be created, so obviously it is not alive, so it will return the false. After starting this one, it will execute what every second, and it will execute what the 10 times, means it will take 10 seconds. 10 seconds this thread will be alive. So in between I am verifying whether thread is alive or not, I am checking. If the thread is alive, so it will return what the true. Now the 10 seconds here to execute this program, it will take the 10 seconds. Now I am waiting for what the 20 seconds, I am waiting for the 20 seconds, and again I am verifying whether thread is alive or not. After 20 seconds, so this thread execution will be done, means this thread will be entered into the dead state. So if the thread is entered into the dead state, so is alive method will be return the false. Okay, now here you will get the answer false. Okay, the same story I am explaining the programmatically now. You can see here. So here I am printing just a simple message, hello message, and thread dot sleep. So here I will take thousands milliseconds, means 1 second. Now I will create a object to the my thread. So t equals to new my thread. Now before that, so I will verify. So before starting thread. Now so thread is alive or not, I want to verify. T dot is alive, I am calling. Now I will start the thread, means T dot start I am calling. T dot start means, so this code will be executed for 5 times for every second. Sorry, every time it is taking 1 second, means total to execute this entire program it will take the 5 seconds. So I will wait for the 5 seconds of time. So again I want to verify. After starting thread, I am verifying. Now, so I want to wait for what 10 seconds, I will take the 10 seconds and again I will verify. So after 10 seconds, thread. Now you can see here, in first case you can see, so before starting any thread, so thread won't be generate anything, means it will be written what the false. After starting a thread, a new thread will be create, means it is a live state, and if the done with the execution, you can see the 5 times it is printing. After waiting for the 10 seconds, I am verifying whether the T thread is alive or not, I am verifying, so it is printing what the false. So during execution, is live method will be written true. After done with execution or before thread creation, is live method will be written the false. So coming to the summary of this session. So in this session I have explained the yield method, the join method, and is live method and current thread method, and some sample examples also explained. Okay, so that's about this session. Thank you.